All right, 8th grade, welcome back. I hope you had a good spring break, and we're jumping into our next problem here, which is problem 4.2 from Say It With Symbols. All right, here we go. All right, area and profit. What's the connection? We're looking at using equations. All right, so in the next problem, you will explore two familiar situations that have been an interesting connection. Tony and Paco will operate the water tube concession stand at Watertown. Tony is responsible for designing the building that will store the tubes. Paco is responsible for deciding the rental fees for the tubes. Okay, so let's go for it. It says here, every concession stand must have a rectangular floor space and a perimeter of 88 meters. Tony wants the greatest area possible. So we need to write an equation for area in terms of length. And what is the maximum area for the rectangle floor space? Okay, so before we do any work at all, we need to make sure we remember all the work that we did back from our little mini chunk of time with frogs, fleas, and painted cubes. We did investigation 1 where we really explored those quadratic functions. And so in this case, we got to go back specifically to remember our work in problem 1.3 and how we develop the equation that's going to fit in this particular circumstance. So if you aren't sure about what to do on those, be sure you go back and check those videos out, and that'll help for this one. But we're going to go and dive in, kind of understanding of what the work that we've done in the past. Okay. All right. So in this case, what we have here is we're dealing with a rectangular floor space with a perimeter of 88 meters. So before we even go anywhere, let's think about that perimeter and that rectangular floor space. So at this point, remember, if I'm going to have a rectangle and I'm going to be dealing with this overall perimeter, it's equal to 88 meters. We got to realize that if you recall, all 4 of these sides all the way around are going to have to add up to 88. So what we need to remember is that these two sides, the length and the width, they're going to equal half of that. Remember? So if I have 88 divided by 2, it's going to be 44. That's our first thing. So these two pieces have to equal 44 meters. We also have to remember that area, in this case, is going to be equal to length times width. We can't forget that. So, but they want us to have an area, in this case, in terms of length for that. So we won't actually have this particular width. We need to have that area. And so to recall, we have to remember there's going to be this understanding where if I'm going to have that perimeter is going to be equal to the 88, but half of that's at 44, so I know that 44 is going to equal to the length plus the width. We need to understand, well, what is width going to be in terms of length? And so if you recall, what we did is we need to get that length out of there. So if I subtracted length here and subtracted length here, I'd be left with 44 minus the length equals the width. And so that's what we can plug in for width. So if I actually go in and I put the length here, that means that this side would have to be 44 minus the length. And so if we recall that area equals length times width, we would know that this particular part for A1, that equation would be area is equal to length times, and remember W is this part here, that 44 minus the length. Now for part 2, they want us to find the maximum area. So in this case, the maximum area, we knew over those other assignments that we were doing, it always equaled a square shape. So if I'm going to have a square, and it's going to end up being an exact square, and the overall perimeter has to be 88, that means I could do 88 divided by 4, and I would get 22. It means all of the sides would be 22. But then what I would do is I would actually do that 22 times 22 to find the overall area. And we would do that by getting 22 times 22, which is going to give me 4 here and a 4 here, add me 0, 4 here and 4 here. So I would get 484 meters squared. So area is equal to 484 meters squared. On to part B. Paco knows that on a typical day, the number of tube rentals, N, is related to the rental price for each tube, P. Records from the other water parks suggest that if the tubes are free, the rental price being 0, there will be 54 rentals in that day. But with each increase of $1 in rental price, there will result in 1 fewer tube rented. So here's what we have, the situation for the equation. So in equation 1, So n is equal to 54 minus the 1 times p. Equation 2, I equals n times p, where I is daily income. So that's what they're giving us. So number 1, do these equations make sense, and explain. So equation 1, what we're dealing with here is the number of rentals is equal to 54 total rentals minus 1 times the price. So if the price is 0, it's going to be basically 0 times that price is going to be 54. But if I put a $1 in there, it's going to be increasing in that case. So this one makes sense. So $54 minus whatever the price is, that's how many rental tubes will be rented. Equation 2, income is equal to the number of tubes rented times that price. So that's what they're trying to tell us in both of those cases. Okay, so we're gonna make sure we understand each of those parts. That takes us to write an equation for income in terms of number of rentals in. So here are our two equations that they just gave us. They want us to write an equation for things to be in terms of n, meaning we're not gonna have p be in there at all. So if you recall, what we just did up here, we did that work to show that what would be happening here to put it in terms of L, meaning we would basically take this value, plug it in for the W. They want us to do some work here to adjust this equation so that we can have everything be in terms of n. So what we're gonna have to do is take this particular equation, make sure we have p all by itself, solving just for p, and then plugging that value p in here for that. And that's what we're gonna end up doing right now. So first things first, we gotta make sure that we're understanding this entire process. So I'm actually gonna drop this 1 here. I'm gonna rewrite this as n is equal to 54 minus p. So what I'm gonna do is basically, I need to get this 54 out of there first. So if I do minus 54 here and minus 54 here, this is gonna cancel. I'm gonna end up with n minus 54 is equal to a negative p. Now this is something that we've talked a little bit about here, but we don't want to know what a negative p is. We're going to use that -1 trick. So I'm going to take all of this times -1 and all of this times -1. So what happens when we do that is this -1 times negative p becomes a positive p, and this -1 being distributed through ends up being a negative n, and -1 times that negative 54 ends up being a plus 54. So that would end up being. Now because of this, addition is commutative, I can remove this around to know that I would actually have 54 minus n is equal to p. And hopefully that looks familiar to what we were doing up above. So this is what this whole thing would equal if we isolate it for p and solve for p in this case. Next, what we're gonna do is take this entire equation that we just solved, this piece right here, and plug all of that in there for p. And if you could watch this really carefully, when I rewrite this out, that's what this ends up looking like. So I will have here specifically, the income is equal to n, and then again we have our parentheses coming in like we've seen for times 54 minus n. And that's gonna look very, very similar to what we did up here. See how we did that same work up here for this first part, and same thing we did in 1.3 for frogs, fleas, and painted cubes. We have that same exact process here. So that's our equation that we would come up with. All right, B3. The expense for storage and maintenance of each rented tube is $10 per day. Write an equation for daily profit, D, in terms of the number of rentals, N. Okay. Before we do anything, I want to make sure we don't forget. Remember, profit is equal to income minus expenses. Now, what they're telling us right here is they want D to be daily profit. So we've got D is equal to, now our income we just did. Income was on this previous page. Income is right here. Income is equal to N times that 54 minus n, I'm gonna plug that in here, equals n times 54 minus n. So there's our income. And then they're telling us that expenses for each day is $10 per day in that case. So what we're gonna have here is for the number of tubes. So here's expense for the storage and maintenance of each rented tube. Remember, each tube is that n from up here, n. So $10 per day, so in terms of n. So now we've got expenses is gonna be minus that 10 times the number of tubes. So hopefully that makes sense. Our income we knew already. We don't forget profit is going to be D, but expenses is going to be $10 times each tube rental, which is $10 per day. All right. So part 4. What number of rentals produces the maximum daily profit? What is the maximum profit? What price produces the maximum daily profit? Okay, so first thing we need to do is we're going to work through this equation here. I'm going to rewrite it, and we're going to actually simplify this to get all those parentheses out of there and get this into a form that we can work with. So in this case, we're going to start off by distributing this through. So I'm going to have D equals 54n. I'm going to have minus here. N times n is going to be an n squared. And that drops our parentheses. Now I got a minus 10n. Now if I look back at this, remember, if I cover this up, I can have a 54n minus 10n, which would give me that the daily profit is going to be equal to 44n minus n squared. So that right there is what we're starting with. We're going to be working with this. All right, so hopefully this is looking familiar to what we've done in the past. We're going to have to go in and plug in values for n to figure out what d equals. This is going to feel very similar to those lengths and finding area. So we're going to do that by making a table of values to see if we can find that maximum daily profit and then what that is actually going to be in that case as well. So let's take a look. All right, so for these values to start off, we'll do 10 and 20 and 30 to see what we end up getting there at this point. All right, so I'm gonna use my calculator here because it ends up being the easiest way to go. So here we go, I'm gonna put 10 in here. So 44 times n is gonna give me 44 times n, which is gonna be 440, minus that 10 squared, which I know is gonna be 100. So that's gonna give me a 340 right there. All right, so next we're gonna do 20. So we'll do 44 times 20, which is gonna give me 880 minus, and 20 times 20 is 400. And that's gonna give me a 480. So there's that. Then I'm gonna do the 30, so 44 times 30, it's gonna give me 1,320 minus, and oops, 30 times 30 is 900. And I'm not sure about that one. Oops, 1,320 minus 900 is 420. Okay, so what we're seeing here, if we follow that same data pattern, how that pattern's been going, as things are increasing, we get this number kind of coming up, but it's coming back down. So somewhere between here, it's starting to come back down. It goes up somewhere and it comes back down. So let's try a number in the middle. Let's try 25 in that case. So I'll do 25 times 44 is 1,100 minus, and then do 25 times 25, it's gonna be 625. So if I do 1,100 minus 625, that's gonna be 475. Okay, so if we look at this here, somewhere between these guys is the middle. This is almost in the same place. So something in the middle of those. So let's take a look what that might be next.